Hello everyone. Today I will show how to configure MPLS using GNS3. But before that you should have prior knowledge of MPLS. What exactly is MPLS? Well, MPLS as a name suggests multi-protocol label switching. It is simple packet forwarding technique which determines the path of the destination address using a term label. What happens in IP routing? Well, each router look for its routing table to get the destination addresses or destination information. In MPLS, it doesn't work like that. It doesn't work like IP routing. Only the routers which are first and the last hop of the MPLS enabled network know the information about destination prefix. So none other MPLS routers which are in MPLS enabled network have any knowledge of or any information of destination. So the first router which is on the edge of the MPLS enabled network will have the information for destination prefix, while the last router which is on the edge of the MPLS enabled network will have the destination prefix. This is made possible due to additional bit which is being attached to the packet header as an identifier, and this identifier is called as label. Now let's see how exactly it works. What is the terminology used in MPLS, because that will be needing it to perform our configuration. Suppose I have got this topology. I have got some routers. If you see on this topology, I have got one CE1, CE2. I have got some PE1, PE2 routers, P1 and P2 routers. Well, P denotes for provider router and PE denotes for provider edge router, while CE is customer edge router. In Cisco environment, the first and the last hop routers in an MPLS network are called as label edge routers, and in the short we write it LER. So PE1 is LER, while all the routers in between them are called as label switching routers, that is LSR. So if I'll show, I have a MPLS enabled network in the center which is encircled, and I've got IP network beside them. I have a customer edge 1 router on one end and customer edge 2 router on the other end. Let's check for LER routers. So these are my LER routers. LSR routers, they are P1 and P2. The MPLS path established between LERs is called label switch path. So LER on one end, that is PE1 and PE2. So whatever is path is constructed between this network, it's called as LSP, that is label switch path. So this is our LSB. I hope you understand the terminology here for multi-label switching protocol. Now there is one more important thing which is, or protocol which is used in MPLS is LDP, label switching distribution protocol. So MPLS uses LDP, TDP or both the protocols. Now LDP is label distribution protocol, which I will be using in my configuration as well. Now MPLS forwarding table. See, both LERs and LSRs are doing label assignment. What they do is they take the IP network and convert into labels. Okay, and they keep exchanging this label information from one router to other routers. This is done by label distribution protocol. Once LDP is established, once this distribution protocol starts working, each router will build their own table. Like IP routing table, it has routing information. Similarly, MPLS forms one routing table, which is MPLS forwarding table. Now LER and LSR, when they switch the labels from one router to other router inside MPLS enabled network, they will perform different types of forwarding techniques. One is IP to label forwarding, other is label to label forwarding, other third one is label to IP forwarding. This starts happening as soon as they receives a IP packet inside the MPLS enabled network. Now one by one we'll see what is IP label forwarding, what is label to label forwarding, and what is label to IP forwarding. Just remember this network diagram. We have got CE1, that is our provider customer edge router, which is connected to our provider edge router, and provider edge router is connected to provider router. Similarly, on the other end, provider 2 router is connected to provider edge router, and provider edge router is connected to customer edge router. Just remember this topology. Now let's talk about IP to label forwarding. As the name says, IP to label, that means it should be happening on the edge of the MPLS enabled network. So that is, this work has to be done by provider edge router. So it is converting IP packet to label forwarding. This terminology refers to label push. So it actually pushes the label to the IP packet, and this is performed by LER in a LSP incoming IP packet. As the name implies, an unlabeled incoming IP packet will be given a labeled tag, which will be used by the next hop router to forward the packet until it reaches the destination. So I have got IP packet coming from customer edge router to provider edge router. What it will do, it will convert into a label, it will switch to a label. So I have received earlier unlabeled packet, which is being labeled by provider edge router. So that is why it is called as IP to label forwarding. Next one is label to label forwarding. Now label to label forwarding happens between the LSR. Now LSR is provider router. So once the label 1 is coming to the provider router, it will forward it to the next router, and it will change it to another label, and it will say label 2. So this terminology refers to label swipe operation. Here we are swapping the label from label 1 to label 2. So this terminology refers to label swipe operation performed by all LSR in the middle of the LSP to an incoming labeled packet. Now here we are not receiving IP packet, we are receiving already labeled packet. LSR will read the label on incoming packet and forward it to related next hop and the outgoing interface. Before LSR forward the packet, it will swipe the label with its own assigned label. The third one, now it is showing L1 is coming and L2 is changed to another label with its own label L2. The third and the last process is label to IP forwarding. Now provider edge router is connected to customer edge router. So it is already receiving a labeled packet. Now it has to again convert into unlabeled packet into IP forwarding, IP packet, sorry. So this is here what provider edge router is doing. It is just removing the label and converting into normal IP packet. So this terminology refers to label pop operation performed by last LSR in the LSP to an incoming labeled packet which is already labeled. This LSR will remove the label from the packet, and the next hop router will continue forwarding it with normal IP routing to the destination. So you can see I received L3 as a label, and then it has been removed to IP packet. So this is the process which happens on MPLS enabled network. It pushes a label, then swipes a label if there is an LSR, and then it pops out a label to convert into again a IP packet. Same process we will be doing for our configuration. Now I will go ahead and pull my GNS3 to show you MPLS configuration. As you can see, I have already designed a network topology with IP networking and MPLS enabled network. We have got some loopbacks. I have converted the router here in GNS3 as PC also. I'll show how to how to use them as a PC. And I've got a MPLS enabled network which is encircled in blue color, while the red part is IP network. So let's start our configuration. First, what I'll do is I'll show you how we can use our router as a PC. I just have to do no IP routing. Now this router will not route anything. This is basically an IP routing. Now I need some IP addresses here. So I'll configure an IP address. Let's take something 10.0.0.0 slash, since I'm using slash 24 everywhere, so I'll use this one. I'll take one more IP here. All right. Now I need to give IP address, interface on which PC1 is connected, FA10, F, or you can write F1/0. IP address 10.0.0. Suppose I take 1 space 255 dot 255.255.0. Like usual, we have to do no shut. Now I need to give default gateway also. So IP default command is IP default gateway. Okay. So that will be my IP address on router port F20. Suppose I take 10.0.0.10. All right. This is it. Now this is my PC1. I'll do the same thing on PC2. Config T, interface FA010, IP address 10.0.0.2 space 255.255.255.0, no shut, IP default gateway, and that should be 10.0.0.10. All right, let me do the same thing here. Config T, interface F1/0, IP address 20.0.0.1 255.255.255.0, no shut. IP default gateway 20.0.0.10. All right, our PCR configuration is complete. Let's start with router configurations. Now I need to configure loopbacks also. I've got 7 loopbacks. Now for loopbacks we don't need to do no shutdown. Alright. Okay, our interfaces are complete. Let's run a routing protocol. I'm running EIGRP. We do. Alright. Now R2 is our LER, as it is on the edge of the enabled network, MPLS enabled network. So LER, provider edge router. Let's go ahead and configure this. Let's go on L3. Now L3 is LSR, that is our provider router. As I told you before, in Cisco we use it terms LSR and LER. Over to last router before running MPLS. All right, EIGRP looks good. All right, time to run MPLS now. Okay, so we have R2, R4, R5 and R3 where we will be running commands for MPLS. Let's go in the command line interface, global configuration mode, IP, CF. Now CEF is Cisco Express Forwarding, and basically it is fundamental switching path for MPLS. Without IPCF, MPLS will not work. We need to see the serial 11 interface serial 1/1 MPLS label protocol LDP. Now MPLS label protocol LDP. This configures the use of LDP on all the interfaces. Now this command is not run globally on the router. We have to run on every specific interface which is coming inside MPLS enabled network. This enables peer label switch router, that is LSRs, in MPLS network. MPLS IP. Well, again, MPLS IP configures MPLS hop by hop forwarding. Okay, so these three are basic commands for MPLS. Let's prepare a cache for CF, and that's it. Now let's go ahead on R3 and enable MPLS. All right. One slash one. Okay. We can even run TDP, or we can run both LDP and TDP both. Okay, but here I'm using only LDP. So serial 11 is complete. Let's go to serial 1/2. Now IPCF, it has to be run on the router, which is done. /12 and 10. Okay. All right. Interface serial 1/0. MPLS MTU 1500. IP root cache. CF, then MPLS IP, then MPLS label protocol, and it is LDP, and we can see the neighbor for LDP is up also. Okay, now let's go on R4. IPCF, let's check the interface. Serial 10, interface serial 1/0, MPLS IP, MPLS label protocol LDP, and MPLS MTU 1500. IP route we don't need here, but still make it CF. So config D, IPCF, let's check the interface serial 10, interface serial 1/0, MPLS label MPLS IP, MPLS label protocol LDP, okay, MPLS MTU 1500, IP route cache CF. All right, so this is it. This is how you configure MPLS commands. Now, as I told you, IPCF, it is fundamental switching path for MPLS. You cannot run MPLS if you didn't run the command for Cisco Express forwarding, right? Then MPLS IP, it configures MPLS hop by hop forwarding on the routers. Then third very important command is MPLS label protocol LDP. So whatever protocol you want to run, you have to mention by using this command, MPLS label protocol LDP. This enables peer label switch routers, that is LSRs, with an MPLS network. So important commands for MPLS: IPCF, then you need to run on interface, MPLS IP, and MPLS label protocol LDP or TDP or both. Alright, now we have some verification commands which we can run to check if our MPLS is working or not. Let's go on our LSR. Our basic commands: show IP int brief, show IP route, check our routing table, and it's working fine. And show MPLS LDP neighbors. So as we can see, LDP neighbor, we can see the connection LDP, LDP, and LDP. Okay, like this we checked our LDP neighbors. You can even check our forwarding table. Show MPLS forwarding table. So it gives us forwarding table. As we can see, pop label, pop label. So these are the labels which have been popped. These are labels 16, 17, 18, 19. This is the format in which the label is made. We can even check our Cisco Express forwarding. Show IP CEF, and we can check our Cisco Express forwarding. So we can see the label has been attached, IP network received, and here it is dropped, that is popped out. What else? Show MPLS interfaces. So we can see the MPLS interfaces which are running LDP. Since this is LSR, so all the interfaces will be running MPLS protocol, that is LDP. This will be different on other provider edge routers. Let's check one more command. Show MPLS LDP discovery. Okay, so we can see the discovery of LDP also. Local LDP 4.4.4.1. discovery sources we are getting from 2, 6, and 5. Let's check these two commands on our provider edge routers. Suppose I take this R2, go to console, show MPLS interfaces. Now as you can see, there is only one interface with LDP, serial 111. Now this is with IP network, where on R3 we had three interfaces with LDP because it is an LSR. Show MPLS LDP discovery, and here we are getting only one discovery for LDP. So this is how we configure MPLS. It is simple and basic configuration. Hope you understood the commands. Hope you understood the concept of MPLS. MPLS is basically very helpful for improving quality of service and traffic engineering. It is reliable and one of the most used technology in most of the industry part. I hope you will get an idea how MPLS works after watching this video. Let me know if this video is helpful and informative in the comment section below. In the next video, what I'll do is I'll perform MPLS VPN. So keep watching for the update. Till then, goodbye. Thank you.